coefficients, which is exactly what we were finishing up with yesterday. So our big focus yesterday was about finding possible rational roots, and we created a list. And then from that list, we learned how to identify one root, which then led us to finding the others. So we're just going to do a couple more like that today. So we have a polynomial function, y equals x cubed plus x squared minus x plus 15. And the first thing I would like us to do is to list all possible rational roots. And so this was what we learned yesterday, is we start by looking at this 15 and factors of 15. You can divide 15 by 1, 3, 5, and 15. And then this is just a 1x cubed, and so really you can just divide it by 1. So we're going to take this entire list and divide all these numbers by 1. And dividing them by 1 doesn't change a thing. So we get a plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. These are our possible rational roots. Okay, we are going to find one that works. All right, and we've got lots of space to do this. We've got the entire front of our notes today to finish this problem. And maybe what I should start with is by saying our goal is to find all roots. So we're going to find all roots. How many should there be? Remember, if this is a cubic, we should have a total of 3 roots. So we're going to find all of them. We know we should have a total of 3. And all of them may be in this list, or maybe only one of them is in this list. Maybe 2 of them are imaginary, right? So that's kind of where we're going here. All right, so when we go to our next slide, it's going to say use synthetic division until you identify one root. All right, well, you know what? I think I'd rather start small, starting with the 1s and the 3s. So again, we're going to use that list. And so I'm just going to go in order maybe. I don't know. I'm going to start with the 1. I'm going to see if that works. So I have a 1, a 1, a negative 1, and a positive 15. Those are my coefficients of the terms in my polynomial. All right, so let's drop that 1. 1 times 1 is 1, and then we add 1 plus 1 is 2. 1 times 2 is 2. We add to get a 1. 1 times 1 is 1, which is not equal to 0, so that one doesn't work. So if 1 doesn't work, maybe the next one I try is negative 1. All right, here we go. I'm going to drop the 1. 1 times negative 1 is negative 1. Add to get 0. 0 times negative 1 is 0. Add to get negative 1. Multiply to get a 1. That doesn't give me 0. So that one doesn't work. So I'm going to keep moving on with my list. I'm going to try a 3 next. Again, my coefficients are 1, 1, negative 1, and 15. Drop the 1 all the way down. 1 times 3 is 3, and then I add to get 4. 4 times 3 is 12. I subtract to get 11. 11 times, oh, that's 33. That's not equal to 0. So that, oh my goodness. All right, well, just keep going. We've got room. So maybe we move on to the negative 3. All right, 1 times negative 3 is negative 3. We add to get negative 2. Negative 2 times negative 3 is 6. We add to get 5. Oh, I love this. Negative 3 times 5 is negative 15. There it is. Finally, we found a root. So x equals negative 3 is a root, which means x plus 3 is a factor. All right, so we know, because we said it already, we should have a total of 3 roots. And right now we have 1, which means we need 2 more. Now remember, by doing this division, we took our polynomial from that first slide and said if we take out that factor of x plus 3, right, that factor of x plus 3, we'll be left with x squared minus 2x plus 5. All right, so we've got lots of room. I'm going to come down here now because it says solve the remaining quadratic. Whoops. This is what I'm referring to. We're going to solve that quadratic to find all roots. So let me just move this down here. We've got our x plus 3, x squared minus 2x plus 5. This one gives us our root of x equals negative 3. We already knew that. Now we want to ask if this factors. It does not. If it did, great, easy. But it does not, which means we're going to use the quadratic formula to find the zeros. A equals 1, B equals negative 2, and C equals 5. So here we go. X equals the opposite of B plus or minus the square root of B squared. I'm just getting that blank template for the quadratic formula. All right, so I'll stick my B in the first two places. My A goes here, and my C goes here. We're just going to clean it up. And we've got all the space in the world to do that, even this next slide here that's blank. So let's see, this turns into a positive 2 plus or minus the square root of 4 minus 20 all over 2. So we have 2 plus or minus the square root of negative 16 all over 2. Well, it's an imaginary number, isn't it? The square root of negative 16. So let's see, the square root of 16 is 4, and the square root of negative 1 is called I. And just like the one we saw yesterday, we can simplify this, right? Draw that little heart there. So now we've got lots of space. 2 divided by 2 is 1, plus or minus 4i divided by 2 is 2i. So remember, we have two solutions here, right? 1 plus 2i, 1 minus 2i. They just happen to be complex or imaginary. And then we have this real solution we found all the way back on slide number 2. So for a grand total of 3 solutions, 1, 2, 3, we have x equals negative 3, x equals 1 plus 2i, and x equals 1 minus 2i. So I'm going to pause for a moment, and then we're going to flip it over and do another one just like it, similar to it. All right. So, same kind of idea. Given the polynomial function 2x cubed plus 5x squared minus 4. First thing we're going to do is list all of the possible rational roots. So again, what are the factors of 4? How about 1, 2, and 4, right? 4 is divisible by 1, 4 is divisible by 2, 4 is divisible by 4. And then we come up to the front, and we look at that 2. Factors of 2 are 1 and 2. And the rule is we take all of these blue numbers and divide them by all of the red numbers. Dividing them all by 1 changes nothing. So we're going to start with plus or minus 1, plus or minus 2, and plus or minus 4. So we just took care of dividing them all by 1. And now we have to divide them all by 2. So I have plus or minus 1/2, plus or minus 2 halves. Oh, that's 1. That's already on the list. And then plus or minus 4 halves. Oh, that's 2. That's already on the list. So it felt like the list was going to be really long, but it's actually not that long, is it? So again, 1, 2, and 4, and then 1 divided by 2, which is 1/2, 2 divided by 2, which is 1, already on the list, and 4 divided by 2, which is 2, already on the list. So we've got 1, 2, 3, 4 times 2, because the plus or minus, we have 8 possible rational roots. Okay, we're going to see if one of these will work. If we can get one of them to work, then we can use the quadratic formula to find any more. All right, so, I typically start with the small whole numbers. That's just me. So, you can certainly start wherever you want. I'm going to start with the 1 or the -1. Now, we're going to use synthetic division. Look at my polynomial. I have a 2x cubed, a 5x squared, a 0x, don't forget that placeholder, and then a -4. All right, here we go. We are going to drop the 2 and multiply, add and multiply, add, and I already see I'm not going to get a remainder of 0, so that one doesn't work. So I'm just going to move on with my list. -1. Again, the coefficients don't change. Drop the 2, multiply to get -2, add to get 3. Multiply to get -3, add to get -3. Oh, that's not going to give me a remainder of 0, so that doesn't work. Let's try the 2. A 4 and a 9, and oof, this is not going to do it for us. 2 doesn't work. I'll move on to -2. Let's see, 2, 5, 0, -4. Multiply to get -4, add to get 1. Multiply to get -2, add to get -2. Oh, thank goodness. -2 times -2 is 4. Look at that. Finally. Which means x equals -2 is one of our roots. Which means x plus 2 is a factor of the polynomial. What's the other factor? Right here. So we've got x plus 2 times 2x squared plus x minus 2. So we could just do a quick check and see if this factors. It does not, and we could certainly play with that a little bit. But that's okay if it doesn't, because we have other ways to solve quadratics, which is exactly what we're going to do, just like on the last one. So we're going to solve this remaining quadratic to find all the roots. How many roots should we have total? 3. So when we're asked to find all the roots, we already know one of them is -2. We just found that. The other 2 come from this quadratic that was left once we took out our x plus 2. So we're going to take that 2x squared plus x minus 2, and we're going to find its zeros or its solutions. Again, I did a quick check. I was going to use the quadratic formula, but I did do a quick check to make sure it did not factor. This one does not, but you can certainly try. So let's see, x equals the opposite of b plus or minus the square root of blank squared minus 4 times blank times blank. All right, so let's fill in what we know. B is 1, a is 2, and c is -2. So we've got x equals -1 plus or minus the square root of 1 minus a -16 double checking all my math in there. So we have x equals -1 plus or minus the square root of 17 all over 4. Now this is not an imaginary number. This is not a complex root. It's just not a rational root because it's got that radical left in it that we can't simplify. But it's still two answers, isn't it? It's -1 plus radical 17 over 4. And x equals -1 minus radical 17 all over 4. So I could have written that a little bit better, and I apologize for cramming it in when I had all this room over here. But we knew we should have 3 answers. There's only one of them that's a nice answer, and the other 2 are irrational. They're not imaginary. They're just decimals that don't end.